Beyond Language Models. Source. Title: Beyond Words. The Rise of Non-Linguistic AI. Author: Dr. Rami Okafor. Published November 26, 2025. Executive Summary. Dr. Rami Okafor explores cutting-edge AI models that operate without language, covering sensory motor learning, swarm intelligence, neuromorphic computing, and vision-based systems. The book reveals how machines can perceive, adapt, and act through interaction rather than words. It challenges the dominance of language-based AI and envisions a future where intelligent systems learn from the physical world, like animals do, redefining what artificial intelligence truly means. Article: Dr. Rami Okafor presents a compelling and timely examination of the rapidly evolving domain of artificial intelligence that operates independently of language-based inputs and outputs. While most popular attention and funding has been focused on large language models, LLMs, like ChatGPT, Gemini, and Claude, Dr. Okafor argues that a quiet revolution is underway in the field of AI, one that doesn't rely on text, speech, or language at all. The book is divided into 6 thematic sections, each exploring a distinct branch of non-linguistic AI. Together, they paint a picture of a future in which machines think and act in fundamentally different ways, not by understanding syntax or semantics, but by perceiving, sensing, and adapting in real-time physical and digital environments. 1. Rethinking intelligence without language. The opening section challenges our human tendency to equate intelligence with language. Okafor draws on cognitive science to show that many intelligent species, such as octopuses, dolphins, or ants, operate with high-level problem-solving abilities without using structured language. This sets the foundation for the book's central idea that artificial intelligence doesn't need to model human language to be powerful or transformative. In fact, in many real-world tasks, robotics, perception, autonomous navigation, language can be an obstacle. Okafor writes, "We've trained machines to talk, but what happens when they need to act? Not just describe, but interact, build, sense, and survive?" 2. Embodied intelligence and sensory motor learning. In one of the book's most fascinating chapters, Okafor introduces the concept of embodied cognition, the theory that intelligent behavior emerges from real-time interactions between an agent and its environment. He examines models like DeepMind's Gato and newer experimental AI agents trained not on language, but on sensory motor data: touch, proprioception, body awareness, and movement. These models are used in robotics, where machines learn to manipulate objects, walk over uneven terrain, or perform complex tasks like folding laundry without textual instructions. This section includes a case study of a quadruped robot trained entirely through physical trial and error. By sensing pressure, balance, and motion, it learned to run across ice and gravel surfaces, something traditional rule-based AI struggled with. Okafor emphasizes that interaction, not internal verbal reasoning, is what drives this kind of intelligence. 3. Multimodal fusion and vision-first AI. Another breakthrough area covered is multimodal AI, where systems combine data from various non-linguistic inputs: vision, sound, touch, heat, and motion. One chapter focuses on vision-first AI models, like those used in self-driving cars, robotics, and medical imaging. Okafor discusses advances in transformer architectures adapted for images and video, such as VIT and Perceiver, where AI learns by watching and identifying patterns over time. These models don't need a dictionary or a corpus. They just need enough visual input to develop predictive capabilities. A particularly compelling example is a robotic arm trained to sort recyclable materials on a conveyor belt. It was trained not through language or programming, but through visual feedback loops, refining its accuracy over millions of cycles. The chapter concludes with a look at sensory integration, where machines combine sound, heat signatures, or touch with vision, similar to how humans process their surroundings holistically. 4. Swarm intelligence and emergent behavior. In perhaps the most thought-provoking section, Okafor explores the rise of swarm AI, systems inspired by the decentralized coordination of ants, bees, or birds. Unlike central models that require massive compute and training data, swarm-based systems operate using local rules, where individual agents respond to nearby signals and, in doing so, create complex collective behavior. These models are being tested in drone fleets, agricultural robots, and environmental monitoring systems. Okafor gives the example of an autonomous search and rescue operation using dozens of tiny drones. No single drone had a map or full knowledge of the environment, but through local interaction and movement rules, the swarm was able to locate heat signatures from stranded hikers. The key takeaway? Intelligence doesn't need to be centralized, or even understood by the individual agents, to be effective. 5. Neuromorphic computing and bio-inspired models. As AI researchers face limitations with energy-hungry neural networks, many are turning to neuromorphic hardware, chips that mimic the architecture of biological brains. Okafor explains how these systems use spiking neural networks, SNNs, that transmit signals more like neurons, allowing for more energy-efficient processing, especially in edge computing and IoT devices. This section explores how neuromorphic AI learns in real time, using fewer parameters but adapting faster. A detailed case study shows how a prosthetic limb equipped with neuromorphic sensors was able to learn a user's walking pattern within hours. No training data, no server, no cloud. These models, Okafor argues, are the future of low-power, high-adaptability AI. 6. The future, ecosystems of non-linguistic and linguistic AI. In the final chapters, the book explores the relationship between non-linguistic and linguistic AI. Rather than framing them in opposition, Okafor envisions a future where the two work together. Language models, providing abstract reasoning and communication, while sensory motor systems interact with the world. He describes upcoming AI systems that can use vision and touch to build something, use language models to describe it, use spatial reasoning to adapt if something goes wrong. This hybrid future will redefine what AI can do and who can use it. The book ends with a call for broader education in non-linguistic AI design, particularly for students, makers, and roboticists. Educational features and audience. Throughout the book, Beyond Words includes diagrams and simplified visualizations of systems like spiking neural networks and swarm patterns, sidebars with AI and nature facts, showing the biological parallels to each model, interviews with engineers and roboticists working on cutting-edge non-linguistic AI projects, a glossary of key terms for newcomers. While the book is approachable for high school and college-level readers, it also offers depth for professionals in machine learning, robotics, and neuroscience. It's ideal for educators, innovators, and anyone interested in how machines can learn without talking. Key themes and questions raised. What counts as intelligence if there's no language involved? Can non-linguistic AI lead to safer, more energy-efficient systems? How do we design ethical frameworks for AI that learns through touch, sight, or instinct rather than text? Could animals' problem-solving methods teach us more than human reasoning models? Conclusion: Beyond Words, the rise of non-linguistic AI is not just a technical overview. It's a philosophical and practical reimagining of what AI can be. Dr. Rami Okafor invites us to look past the hype of chatbots and LLMs and into a world where machines don't just talk, they sense, adapt, and act. With real-world examples, scientific rigor, and an eye on the future, this book challenges readers to think differently about intelligence, technology, and what it means to build machines that learn like life itself.